So last time we talked about was it binary, uh, back and forth between binary and decimal. Well, let's actually upgrade that a bit. So we talked about binary and decimal, but we didn't talk about is something rather important, which is what if we're dealing with fractions? We haven't actually mentioned that yet, but if we're dealing with fractions, so let's see what we're talking about there. We have our powers of 2, so 1, 2, 4, 8, 16, 32, 64, 128, right? I can keep going and on, and I'll stop at 1024. Okay. If we want to deal with fractions, okay, so let's just mention that. So with fractions, okay, what to do? Let's take a look. So as before, we have our places. So just mention those places here. So we have our ones, we have our twos, our fours, our 16s, and our 32s. Okay. We also have in binary, if we're dealing with fractional numbers, we have a little dot here. By the way, this is not known anymore as a decimal point. So a decimal point, by the way, would refer to base 10 because, well, we have decimal, but binary is not decimal. Binary is binary. So instead, the more generic term to use instead is not decimal point, but radix point. So radix is just another term for base. So this is a point that refers to at what point that we're going from our whole numbers to our fractional numbers. So on the left-hand side, we have our whole places. So remember, these are our places. And these are our values over here. Or digits, I should say. And to be more accurate, I'll say bits. But you get the idea. So to the right-hand side of this radix point, we have our fractional parts. So you might wonder, well, what's that going to look like? Now, just to review really quick, if we were dealing with, just scroll to the side for a second, just a little aside, because we're going to the side, go figure. If we were dealing with, say, like 10.75, right? If that's our number, say, 10 and 3/4, right? Well, we have our decimal point here. To the left, we have the whole part, and to the right, we have our fractional part. This, by the way, just to review, this would be our 10 to the 0 spot. This is our 10 to the 1 spot. This over here is our 10 to the negative 1 spot. This is our 10 to the negative 2 spot. So actually, I mean, this would be our 10. Another way of saying this is our 10s. This is our 1s. This is our, I shouldn't write it this way. This is our tenths. This is our hundredths. Okay? So, as it turns out in binary, that's rather similar in terms of what we're doing. So if we go back over here, right, instead of having our tens and our tenths, so we'll have instead our halves, or maybe I should say halves, okay. We'll have our fourths, we'll have our eighths, and our 16ths, and then our 32nds. You know what? I think I found a mistake already. 1, 2, 4, 16. What? That's crazy. That's wrong. Okay, so if you noticed that earlier, good for you. If you didn't, you're in good company. Okay, so let's fix that. That should not be 16 and 32. The next power of 2 is eighths, so I should say our eighths. These are 16ths. 16s, not 16ths. See, I'm all sorts of confused. Alright, 16s. Nope. Anyway, okay, just a little aside. Okay. Alright, so maybe just for fun, I'll just put our 1, our 2, our 4, our 8, and our 16 over here. And over here, I'll say 1/2, our 1/4, our 1/8, and our 1/16, and our 1/32. Okay, good times. Alright, and likewise, just for completion, right? I mean, this would be our 10 spot. This is our ones. This is our 1/10. This is our 1/100th spot. So you see, there's an order to this. Okay, so going back to binary. Okay, so back to binary. Suppose I have some random number here. I'll just say 10010, and then I'll have 10100. Let's say. Okay. All right. So this number here is going to be. I mean, I can just do this really quick. We have 16 plus 2. That's going to be in decimal. This part. If I just. By the way I'm doing this, I should say, is I'm going to look at these separately. I'm going to look at the left-hand side, which is our whole part. And then I'll look at the right-hand side, so our fractional part. And I'll do these separately. And then I'll just join them together to do the conversion. So, first we'll look at this part, because we know how to do this already. So 16 plus 2, that's just 18. Okay? Dot. Okay, and then I'll look at this part. So this is where we just, we do the exact same thing as before. We sum up the place value times, the place times the value. So 1/2 times, let's see, so times 1 is just 1/2. Let's see, 1/8 is, let's see, that in decimal, say this is 0.25, this is 0.125, so this is actually, I should say, this is just over a little side over here. We have 0.5 plus this is going to be 0.125, just to make sure we're doing this right. It's going to be 0.625, so 18.625. Okay, so that's what this number is in decimal. There you go. All right. Now, the strategy, the algorithm for converting from decimal into binary is going to be exactly the same. So let's look at our example that we had earlier. So let's go back over here. So here we go. Whoop, 10.75, right? 10.75. If I want to convert this to binary, okay, I have to do. It's going to be the same basic strategy. I'm going to take what's on the left-hand side, the whole part, and then I'll look at the right-hand side. I'll look at the fractional part, and I'll look at those separately. So 10 in decimal is what in binary? Well, again, the algorithm, let's go by the algorithm. We find the highest power of 2. So the highest power of 2 that can go into 10 is actually 8, right? So I'll write down my 1s, my 2s, my 4s, and my 8 spots. So 8 can go into 10, so that's our, just write these out. Okay, all right, now 4, so let's just keep track. So we have 10 minus 8, right? What we have left is 2, all right? Now 4 doesn't go into 2, so I'll just write down 0 over there. But 2 does go into 2. And now we're left with nothing, so 2 minus 2, we have nothing left, so, well, 1 doesn't go into that, so we end up with 1010. Okay, so now I have my radix point, or now, I'll have my radix point over here, and now we have 0.75, so let's just write our places out. So we have our half spot, and we have our 1/4 spot, and, well, actually that might be sufficient. We'll see why. So what I do is I say, okay, well, what's the highest power of 2 that can go into 0.75? Well, that would actually be 1/2, because 1/2 is just 0.5, so 0.5, right? This is actually a really easy example. This is going to leave 0.25, so we'll write a 1 there, and, well, 1/4 is just going to be, that's what that is. So if I subtract away 0.25, because that's what 1/4 is, right? We end up with nothing. So there you go. That's what this number is in binary. So this is our decimal over here. We have our decimal spot, or our decimal. And over here, we have our binary. And that's doing with fractional parts. Now, the fun thing about this conversion, let's take a look at one more conversion before we call it a day. Suppose we're dealing with just this number here, 0.65, okay? All right, and before we really talk about that, I just want to mention something about precision, okay? This is not really an issue for the whole part, it's more for the fractional part. So this fractional part is always giving us headaches, okay? Here's why. Before we get to 0.65, let's think about something that's really like 1/3 in decimal can't be represented exactly. That's like 0.333 on and on forever and ever, okay? So we can't represent this number in decimal exactly. Now if this were base 3, if we were representing 1/3 in base 3, that'd just be 0.1 in base 3, but that's outside the scope of this discussion. But in any event, if we take a look at 0.65 and we want to represent that in binary, what we would end up with is something that's kind of something tricky. So let's write this out over here. So we'll have 0, and then we'll write that out. So we have our halves, we have our 1/4, we have our 1/8, our 1/16, 1/32, 1/64, etc. Okay, so 0.65. Okay, well, half can go into that, so that's 0.5. So that leaves 0.15, right? So right of 1. So as it turns out, 0.25 cannot go into 0.15, so we'll write to 0 for that. Now 1/8, that's 0.125, so I can, if I subtract this out, I have 0.125, okay? That leaves us with 0. Let's see, this is 5, so it's 0.25, or 0.025, I should say. Okay. So, right, so it looks like 1/8 goes into that. Now 1/16, let's see, 1/8 is 0.125, and just remember this, so 1/16 is going to be 0.0625. Now 0.0625 does not go into that, so I'll just say that. Okay. Now 1/32, that's going to be in decimal, it's 0.03125. Yep. So that doesn't go there, so there we go. But 1/64, that's going to be 0.0, I think it's going to, yeah, 15625, if I did that right. You can double check that really quick, but I think that's right. Now that actually does go into this thing over here, right? So if I spread that out, 0.15625, well, okay, alright, this is where it gets a little hairy. I could keep going, 1/128th, and, well, at some point we're going to kind of get tired of doing this, but, right, let's see, so, but before we do that, let's take a look. Yeah, okay, so let's just double check this. Okay, so we have, let's just do the subtraction really quick. So, let me just do that. Boy, that's, okay, so that's going to be 5. So we know that's what that's going to be. So now we have to pull some things in. So let's just subtract this stuff out. So, okay, so this is going to be 4, 9. So, oops, you know what? I think I goofed that up. That should be, yeah, because we have to pull it in. So that's going to be 7. 9 minus 6 is going to be 3. 4 minus, oh, okay, so that's going to be 1, this is going to be 14 minus 5. 14 minus 5 is going to be 9. Okay, and that's just going to be 0, 0. Okay, great. So there we have it. So, okay, well, and I don't know what 1/28 is off the top of my head, but in any event, you notice that, I mean, if we could keep going, but you notice that this value over here, right, represented very nicely in decimal, right? That looks nice, but in binary, it's rather hairy, actually. It's really kind of hairy. Now, as I understand it, this number is kind of analogous. It's the same. This in binary is analogous to this number here in decimal. You cannot represent this number exactly in binary, as it turns out. You can try that on your own. I'd like for you to keep trying this, but in any event, you might notice when you are dealing with floating point numbers that the number that you put in, like say 0.65, is not necessarily going to be the same as the number that you get out when you say print that number out, like some binary number. And the reason for that is because of this problem where we only have a fixed number of bits to work with, right? So we have computers that are finite in some sense. So we only have a finite number of bits to deal with, and so that means we can only represent fractional parts with a certain level of precision, and then beyond that level of precision, we have nothing left. But we can run into this issue very, with some pretty simple numbers like 0.65. So it's kind of an interesting problem. So this is another reason why, by the way, if you're dealing with, say, currency, you would never want to use a float. For currency is kind of a bad idea. So float for currency is kind of a big no-no. I would say you say big no, don't do that, right? So yeah, so don't do that. In any event, that's what I wanted to get out of this lesson today about doing binary to decimal conversions. Oops. With fractions. So we're dealing with fractions now. So there you go. So that's the long and the whole of it.